Great. So I think we're now open as a webinar. Okay. So welcome everybody to today's session of Common LA, which is going to be an industry panel. Thanks to all our speakers who've agreed to participate in the panel. It looks like it's going to be really good. So just before we get started, a few housekeeping rules. We're going to start with some prepared questions. So each speaker is going to introduce themselves for roughly 1 minute. Then we are going to, we have a list of prepared questions. If you have anything you'd like to ask the speakers, ask in the Q&A. Basically, all speakers who think that they have something particular to say about a question can hop in. And then that's going to go on for half an hour. And then at the end of the session, we're going to move to Gather. You should have received the link in the email. And then in the Gather, I'll talk a bit more about the Gather session at the end to give some kind of advice on how that will work. Okay, so if we could, right, panelists, welcome. And if you could just go in the order that we previously discussed and introduce yourself, what you did your PhD in and what you're doing now. Thanks.
Hello, everybody. That means I'm first, right? Like, so we do this alphabetically. Okay, well, nice to get back in touch with like the numerical linear algebra community, of course. Kind of missed you guys. I did my PhD in TU Delft in 2013 on a topic that was preconditioning linear solvers for elasticity problems together with Shell. I had a supervisor also in Shell, Netherlands. So yeah, we were simulating wave propagation problems, and so I guess that these 4 years, 2014 to 18, were really the time I was in this community. So then I finished that and moved on to do a postdoc in Magdeburg at the Max Planck Institute. It was again a rather applied topic, I would say. It was together with the energy with some energy companies in Germany trying to optimize and simulate like the electricity grid. So there's I guess a lot of kind of new challenges that come with the energy transition that is kind of getting into place. And yeah, so and then so I did this for almost 2 years, and finally ended up in January this year at Philips Research in Hamburg. So it's again a pretty different mathematical topic again. So this is, I mean, I guess I don't have to introduce the company. So Philips kind of well known, I think. So they do well, TV and toothbrushes, but what they really do is healthcare. So we have MR systems on our floor and well try to improve medical imaging problems, basically make better image quality, make the scan, so the acquisition time, the time that somebody is in the scanner faster, and maybe also less noisy, and work on, of course, on imaging problems. So yeah, reconstruction, that is. And well, is that my minute is over, I think. So I'm very happy to get in touch with you. See you later.
Hello to everyone. I'm very happy to be here too, and it's very nice to see you all. Also you, Manuel. It's a long time, but
yeah, that's true.
I'm happy to be here. Thanks for the invitation. I did my PhD also in the Netherlands, in Eindhoven, and I worked on large dimensional matrices, and I approximated eigenvalues and singular values with Langshos methods. This was I started in 2013. I think the same as Manuel, yes. Then I worked for 2 years at the University of Utrecht as a junior assistant professor. And then I decided to move to Italy, where I'm now working as a calibration algorithm engineer in a not really small company anymore. They started in 2012, and they're now we're almost 90 people now working there. It's growing very, very fast, and my company makes navigation units, navigation systems. And in this unit, there are 3 gyroscopes and 3 accelerometers, let's say in general, with which you measure acceleration and angular rate, with this data you can do navigation. So these are inertial systems, so there is no use. Well, you can use also GPS, for instance, to as aid, but the systems work all by themselves. And my function in the company is the calibration algorithm engineer. So I'm still working a lot with MATLAB on a daily basis, which makes me very happy. And I do a lot of optimization since I have to calibrate the units. So there are models in temperature, for instance, that model all these sensor outcomes, and I try to find the best calibration for all the units. So that's what I'm doing. I think next. Thank you.
Hi, I think I'm probably next alphabetically. So I'm going to try to share a slide with you.
Okay, yeah, that's great.
Hopefully I'm sharing this. So I'm working in the data science team in N Brown, and I will in a minute tell you what N Brown is. But how I got here is I did my PhD at the University of Manchester on matrix functions. I then went on to work in Bloom Agency as a data science consultant, essentially. And now I'm at N Brown. How I've transitioned is from matrix functions, we did a bit on applications to large-scale networks, which has brought me to analysis of social media data and market research. And it was quite fun to work with some really big UK brands. And we did, for example, impact studies on Just Eat advertising during the X Factor campaigns. And yeah. It's quite fun. And I then moved on to work for N Brown, which is, it's an e-commerce company holding name for a few different fashion brands. For those who are in Europe, probably competitors are Otto or La Redoute. So traditionally a catalog business that is now transitioning to everything online. So we try to optimize everything a customer does on the website and to really tweak their experience. But some of the more fun projects have been predicting customer sizes for clothes and really optimizing the shape of the clothes, because we have technology to take 3D measurements of the customers as well. So I'm not actually staying for the gather session. So if you'd like to chat about anything in particular, please find me on LinkedIn or Twitter. Yeah, that's for me.
So I think, Peter, you're next.
Hi, sorry, I was muted. I was starting to talk and nobody was listening. I did my PhD in Innsbruck in Austria, working on exponential integrators, but drifting off to numerical linear algebra, more or less, and doing matrix functions mostly. I even did an exchange to Manchester, so I know Mary. Hi, Mary, by the way, I forgot in before. I'm currently working at Adenbach. We are doing everything that has to do with light. So we do lighting design, outfitting universities, I don't know, museums, private homes, everything, airports, and also doing research and development in what is light, how is light affecting people, how is light affecting the environment. And I'm in development, so we actually produce or we compute reflectors, lenses, different applications for customers all over the world. So we are not just producing stuff for our company and then selling it, but we are more of an engineering office that big luminaire manufacturers come to us and ask us for something, or I don't know, at the moment we're doing a lot for medical, as a lot of other people doing. So we're doing a lot of medical luminaires for operation tables and stuff like that. I think that's from, oh yeah, and how I got the work. No, that is later, sorry.
Hi, everyone, Kyle Closter. I did my PhD at Purdue University in the math department. My advisor was in the computer science department, so it was a little bit one foot in each world, focusing in graph theory and linear algebra, like a lot of the folks here, specifically in network science. So matrix functions and their applications and things like community detection, graph analysis, machine learning applications. So after finishing my PhD at Purdue in 2016, I took a postdoc in the computer science department at North Carolina State, where I worked in algorithmic optimization, usually on graphs. And after about 2.5 years, I moved out to the San Francisco Bay, where I am now, working at a startup company called Carbon 3D. We're a 3D printing company that the technology that Carbon introduced that differentiates from previous 3D printing companies. Instead of most 3D printing companies print sort of like an inkjet printer, where it's a printer head that zooms back and forth on a 2D image and prints a 2D image. Most 3D printers print a 2D image and then print another one on top of that and another one on top of that. And Carbon takes a pool of liquid resin and prints an entire 2D image at once, and then lifts the printed part out of this liquid pool. It's pretty cool. I've sort of drank the Kool-Aid, as you can tell. I think it's pretty cool. So what do I do there? So 3D printers, they need 3D models of things. So I work on the geometry team as a software engineer, where we come up with, I like to tell people basically, we make sort of Photoshop software that instead of letting you edit 2D images, it lets you edit 3D objects. So if you want to texturize an object or warp an object or get it just so, and then model how does this 3D object, what are the physics of it as it comes out of this pool of resin, modeling that, all that requires a lot of linear algebra, and the geometry modeling requires a lot of graph theory. Yeah, that's me.
All right, I guess I'm up next. Thanks for having me today. It's really nice to be here with everyone and see a lot of familiar faces. My name is Scott Ladenheim. Let me just share my screen quickly. I did my PhD in 2015, or I got it in 2015 from Temple University. My dissertation was on preconditioning of saddle point problems, especially those that arise from coupled fluid flow systems. After that, I did 2 years at as a postdoctoral research associate at the University of Manchester, working in the School of Computer Science, where I built some software to simulate basically heat flow across computer chips. And then after that, I took a job in a startup in Delft in the Netherlands called NextOcean, where basically I was developing software that read continuously a ship's radar and motion sensor data to predict future motions like heave, pitch, and roll of a ship. And then after a couple of years there, I moved on to a global data analytics firm called Tesella. And so at Tesella, I've worked on a range of projects ranging from more data science kind of things to software engineering. So I've worked doing things like querying databases, building front-end user interfaces, and also doing many kinds of statistical analysis kinds of things. So it's a real jack of all trades kind of job. One of the benefits I find of working there is most of the staff hold PhDs, so you're working in a really, so in terms of moving from academia to this position, I feel like I'm with a lot of other very qualified and smart people with a range of experiences. There's also a lot of opportunities for machine learning and data science training, and they even have their own in-house research program called Cortex, where you can basically apply for a 3-month, you basically write a research proposal, and then you have 3 months on your choice of machine learning AI application. So I think that's it from me. So I guess, Ian, you are next.
Yeah, thanks for introducing me. I'm Ian Zwan. I did my PhD in the Technical University of Eindhoven. I actually shared an office with Sarah. And after my PhD, I did a postdoc in Wuppertal. And after that, I went back to the Netherlands and joined ASML. For those of you who don't know, ASML is the second largest technology company in Europe by market cap. And they make photolithography machines, and they're the world leader in that. And all the major chip makers are customers of ASML. So if the CPUs, the GPUs, the memory chips, the storage in your phone and laptop and computer are all made with machines from ASML. ASML also makes metrology devices, and I'm working in a group that works on creating algorithms and software for those devices. So that was my elevator pitch. And I think I was the last, so.
Yeah, great. Thanks everyone for those really good introductions. So we're going to start on some questions. So there have been some questions in the Q&A, and some of our speakers are answering those. But I think we're going to start with a prepared one. So what's the biggest difference between your current day-to-day work and when you were in academia, and kind of from a working perspective, and also maybe a quality of life, depending on what you have to say? So just jump in if you have a response.
Well, I have a reply for this. So maybe it's also the global situation in which we are now. I'm a large part of the day I'm like this on the phone with colleagues. But I also, when still in the company, I was talking to many people. So maybe because of the company, it's growing very fast. So I'm talking to people from the production of the units. I'm talking to people that design the software, hardware. I have to call everyone or talk to everyone because we're just creating new units. So I think that is the biggest difference for me, is that I'm collaborating with a lot of people, much more than before. And this is something I really like. Maybe you could say, well, I miss the contact with the students, but since there are very many young people also in the company, and people have to learn from each other, it's almost like a university sometimes. And I even have taught to another company, so there are also similarities, but the largest difference is, I think, talking to many more people during my day.
I agree with that. Actually, it's the same. It's the same in my job. I collaborate a lot with all the different departments, and it's really necessary to make sure that we build something that is fit to purpose and that does get implemented after we're done with the maths of it as well. Yeah, definitely a lot more than when I was a student.
I would say what is a big difference for me is the time frame. So at universities, usually you had, well, your project had a bit more time. Your deadlines were a bit flexible. If you have to produce for tools for a couple of €100,000, the time frame is a bit more on the bad side. So there's more pressure. And, yeah, something like that is a bit higher than at university.
Yeah, in my case, it's not only like communication with other, professions, but also that I have to do actually measurements. So that was kind of something I didn't do before in academia. So yeah, we have this MRI on our floor. I mean, algorithm really only kind of works if you kind of test it there with actually patients kind of in it, and I kind of learning how to kind of do proper measurements, so like kind of experimental work. That was something I had to kind of learn quick. Like,
Great. So it sounds like quite a lot of differences to what you were doing in your PhD. And what skills or experiences do you think were most helpful that you had during your PhD for your job now? And is there anything that you wish that you had more experience in before you moved into the industrial workplace?
Well, for me, in terms of, I think the mathematical background is really useful in terms of understanding machine learning algorithms and being able to analyze things. A couple of things I wish I knew or used a bit better were version control, for instance, Git. That is like one of the biggest lifesavers that I've found in my work. And like, if I knew a little bit of the basics when I, was doing my PhD and postdoc, but like when you really use it a lot and you get very comfortable, it's really, really useful. And I also would recommend like principles of software design if that's like the kind of work that you end up doing as well. That was also something that I've picked up and has been really useful. So.
For me, one really useful skill is just all the experience in experimental design and data analysis that would come up from the experiments sections of the papers that I worked on in labs. Having a good sense of how large a data set you need to test something, developing an intuition for what are good things to look for as I'm testing out this method to see if it's going to work for the problem that we need solved. Just experience the wisdom that can only come from running a bunch of your own experiments and defining the parameters yourself.
I think what's been really useful for me as well is the research mindset. So when there is a new problem, we first think about surveying the literature. Has anyone else ever solved this problem? And going a bit of a deep dive and then trying to even approach the problem in a more scientific method. And this is definitely something quite useful and transferable. Other than this, probably the standard set of skills, sort of presentation skills, writing, scientific writing.
Ian, I'm aware you don't have a video, so is there anything you wanted to comment on?
Well, I think I can add a difference with academia. Instead of something that transfers over, something completely new is maybe the politics inside a company. So ASML is not too bad, but at the same time, it's also a pretty big company, and you have a product that's actually at the customer. So if you have a new idea, you can't just say, well, I'm just going to implement it and then see what happens. Because if a customer has downtime, they are definitely not happy. And if you even change something, then they, for example, like an indicator for how well the software is working or whatever, and you change it, then you also have to communicate that change. And people don't know how to interpret the new measure compared to the old one. So yeah, there are some. If you have a new idea, you need to figure out how to push it and how to get people on board with it. And that's well, I suppose if you write your own research proposals in academia, then that might be similar, I suppose, because you also need to sell it. But most PhD students, I don't think have experience with that.
Thanks, that's a really great point there. So we're coming to the end of the panel session already, which is amazing. But just to finish up, we've had a question about whether you are able to continue publishing in academic journals, and kind of more broadly, are there things that you are not able to do compared to a PhD or postdoc that you miss doing? Or is it kind of just nice to be in this new job?
Well, the publishing is yes and no. I know that some people with an ASML publish stuff as part of their work, actually. Sometimes it's also necessary to publish stuff because we have a department for intellectual property and patents. And sometimes they decide not to patent something, but still want to make sure that prior art exists. So then, then you need to publish. But in my group, I don't think there's really any publishing going on. And myself, outside of work, I still need to finish 2 revisions of papers, but honestly, I don't have much time for it. And it goes at a snail's pace.
Yeah, I think the situation for me and Philip's research is a little bit similar to Ian and ASML. So we can still write papers. We actually work together with a lot of universities, but then it's more that we give, let's say, support. So like a PhD student would come and they work with the Philips MR scanner, and then they sometimes visit us. So of course now with COVID-19 not so much, but in general it's appreciated to support when, let's say, in projects where there's publications at the end. So that's definitely possible.
I think what is quite underestimated as well is in academia the possibility to travel to conferences, and that's usually paid for. That's the dream of the past, I think, for me.
Well, but some companies have still some travel. I mean, I have a colleague right now in South Korea. I think he has to quarantine for 2 weeks. That's another story.
Tesela, where I work, actually, well, before COVID, they would do a yearly conference in the UK where all the company members would come and join, and you have the opportunity to give presentations about stuff you've worked on or other interesting things that you may have done. Also like training opportunities, things like that. So yeah, in terms of, okay, it's only once a year and it's, usually always in the UK, but you do get a little opportunity to travel there.
For my company, we have a couple of fairs that we attend. Well, we did attend, not this year, of course, but this is a different kind of workload. You have to talk basically the whole day, try to sell products. So it's very different from a conference, but still, you get to travel around a bit. So I attended some fairs in the US, in Europe, and in Austria. So you can do more stuff.
I think in my situation also, my family situation counts, because I think there's a lot of innovation going on in my company. So if I would like to write also papers on things I'm working on, that I did not try it yet. It might be possible. I think so. I mean, some people do, but also my family situation with 2 small little girls. I don't know where to find time to do also this. So I mean, it's not the main goal of my company to publish. So yeah, I think the possibility is there, but I have to make choices regarding time.
I have something to add as well. I forgot. So we have the possibility, as we do research, to publish as well. It's slightly different because it's more psychology journals and not numeric journals. But also we get to work together with the norming institute, so we can help on defining norms, even European norms. So this is also quite fancy.
Great. So that is, in fact, 2:30. That's gone really quickly. Thanks to all the panelists. I think it's been really interesting hearing what you have to say. But the good news is we're now moving over to Gather, and so the audience will have an opportunity to interact with each of the speakers. So a few tips and instructions. The link should have has gone out by email, and it's a bit of a different setup to what we normally have. So basically, each participant has a room, and we'll go to the room. So if you wish to speak to someone in particular, you can go and find them. But the walls are not physical walls. So the closer you are to people, the more you can hear them, but the sound isn't blocked by the walls. So if the speakers could try and stay in the middle of the room, that would be really helpful. In general, if the clusters get too big, sometimes you can be caught between two conversations. So if you can't hear, just try moving your avatar around a little bit so that there's less interference. I think that was everything on my list. Oh, there's one more thing. Where is my slide? Here we go. So just a promo for next week's talk. So next week we return to the usual talk setup with networking afterwards. So please do join us to hear some more fantastic talks. I'm particularly interested in this one about face recognition while we're wearing masks. So see you all in Gather in a second. Also, if you haven't used Gather, sometimes it conflicts with Zoom, so close the Zoom window first before you launch Gather. And see you all in a bit. See you all in
May I still ask a question, or maybe can I say still something?
Yes, people might be leaving, but sure.
Yes, okay. So for those who are still there.
We're still here.
Yeah, you're still here, so okay. I would like to say that if you're talking to other people and you would like to ask me as well something, you always can contact me via LinkedIn or Facebook or email. That's really not a problem. So, as also Mary already said, so please contact me. And I'm a bit afraid of this room we're going to now. So if I'm lost, please call me, or can I call someone?
Yeah, we'll try and help.
Okay.
Hopefully it won't happen.
Okay.
Okay, see you all in a bit.
See you there.
Bye.
Bye.